you. Welcome to all of you. Today we discuss about MCQ paper CC-11 2022 semester 5 B.Sc Honors in Mathematics Probability and Statistics paper. Question paper CC-11 Mathematics Honors. Question 1a. For any two events A and B, probability of A equal to 1 by 3, probability B equal to 1 by 4, and probability A union B equal to half, then conditional probability A by B. We know the conditional probability A by B, this equal to probability A into B by probability B, provided probability B not equal to 0. Now the probability of A union B equal to probability of A plus probability of B minus probability of AB. So here probability of A union B equal to half, probability of A 1 by 3 plus probability 1 by 4 minus probability of A into B. So probability of A into B equal to 1 by 12. Hence from 1, probability A by B equal to 1 by 12 divided by 1 by 4 probability of B. Hence 1 by 3. So correct answer is 1, option 1, 1 by 3. Next question 1b. The probability density function fx equal to x when 0 less than x less than 1, 2 minus x when 1 less than equal to x less than 2, 0 elsewhere. Then the value of probability half less than x less than 3 by 2. A distribution function capital Fx, this equals to probability of minus infinity less than capital X and less than equal to small x. This equals to integration minus infinity to x small x probability density function fx dx. Here probability of half less than capital X less than 3 by 2. So this equal to integration half to 3 by 2 fx dx. Because probability of A less than capital X less than equal to B, that is equal to capital FB minus capital FA. So here if we put here equal to sign, then probability of 3 by 2 x equal to 3 by 2, this equals to 0. So we can write this integration limit half to 3 by 2. But here this 0 to 1 and 1 to 2, there are two intervals. So half to 1 and 1 to 3 by 2. So 0 to 1 fx is x and 1 to 2 fx is 2 minus x. So put these values of fx and after integrating we find this probability, required probability is 3 by 4. Hence correct option is 4. Answer 3 by 4. Question C. If Ex expectation of x equal to 3, expectation of y equal to 5, then covariance of xy equal to 2, then find expectation of x into y. Covariance of x and y, this equals to expectation of x minus x bar into y minus y bar. Here x bar is the mean of x. You can write mx in place of x bar, or y bar equal to my, mean of y in place of y bar. After simplification, we get this equal to covariance of xy equal to expectation of x into y minus expectation of x into expectation of y. Now covariance of xy equal to 2. So put here 2 and expectation of x equal to 3 and expectation of y equal to 5. So we get expectation of x into y equal to 2 plus 15 equal to 17. correct answer is 1. Next question D. If fx equal to k bracket 1 minus x square minus y square, 0 less than x square plus y square less than 1, and 0 elsewhere, is a probability density function of two random variable x and y, then value of k is what? Here the double integration, this minus infinity limit of x is minus infinity to plus infinity, y minus infinity to plus infinity, fx comma y dx dy equal to 1. So here the domain is this 0, so this is a unit circle. Inside the unit circle except the point 0, so this is, so value of y equal to minus root over 1 minus x square to y root over 1 minus x square. This is the region inside the unit circle. This. Now we transform the polar coordinates to polar coordinates of this function fxy. So put here x equal to r cos theta, y equal to r sin theta, and the Jacobian J is the determinant of del x del r, del x del theta, del y del r, del y del theta. So this Jacobian J equal to r. So this expression 1 becomes this fxy, this k into 1 minus bracket x square plus y square, so k into 1 minus r square into Jacobian into dr d theta. Here Jacobian is j is r, so put here r. So and the limit limit for r, this equals to 0 to 1, because this is the unit circle from r equal to 0 to 1, and this theta expression in the anticlockwise direction, theta equal to 0 to theta equal to 2 pi, then we get a complete unit circle here. So this equals to, after integration with respect to r, this r square by 2 minus r to the power 4 by 4, limit of r 0 to 1, this d theta, integration over theta 0 to 2 pi equal to 1. Hence this theta, so 2 pi half this, and k equal to 2 by pi. Hence correct option is 3. Question E. The moment generating function of a random variable capital X uniformly distributed over the interval, open interval, minus 1 1 is given by this. Now the moment generating function of capital X is equal to capital mxt, that is equal to a to b integration e to the power tx 1 by b minus a dx for a uniform distribution within interval a and b, open a comma b open interval, this. So this is the, after integration we get this t not equal to 0, and if t equal to 0 we get this equal to 1. So moment generating function of x mxt is equal to minus 1 to 1 integration e to the power tx 1 by b minus a, that is 1 minus minus 1, so 2 dx. Here x is uniformly distributed over the interval minus 1 to 1. So after integration, hence we get 1 by 2 t to the power t minus e to the power minus t, and this equal to sine hyperbolic t, hyperbolic sine t by whole divided by t, because e to the power t minus e to the power minus t whole divided by 2 equal to sine hyperbolic t. So correct option is 1. Question A. If the mean and standard deviation of 10 observations x1, x2, x10 are 2 and 3 respectively, then the mean of x1 plus 1 whole square, comma x2 plus 1 whole square, x10 plus 1 whole square is what? Here expectation of x that is equal to small n equal to 2 is given in the question, and the variance is, the standard deviation is 3, so variance, that is sigma square is 3 square, sigma square is 3 square, and sigma square variance equal to expectation of x minus m whole square, so e of x square minus m square. So sigma square means 3 square because sigma is standard deviation. This e of x square minus 2 square, m is 2. So e of x square equal to 13. Now this is the variable, this x1 plus 1 whole square, x2 plus 1 whole square. So we can write this expectation of capital X plus 1 whole square. So expanding this equal to expectation bracket x square plus 2x plus 1 equal to expectation of x square plus 2 expectation of x plus 1. E of x square equal to 13 and this e of x equal to 2. 2 into 2 plus 1 equal to 18. Hence correct option is 2. Question G. Let x be a binomial random variable with parameter n and p where n is positive integer 0 less than p less than 1. If alpha equal to probability of modulus of capital X minus np greater than equal to root n, then which of the following statements holds true for all n and p? Now from Chebyshev inequality, probability of modulus of x minus m greater than equal to epsilon, this less than equal to sigma square by epsilon square for any epsilon greater than 0. Here m is the mean and sigma square is the variance of the random variable capital X. Now here capital X is a random variate binomial NP distribution where 0 less than p less than 1, and so in the mean of this binomial variate X, Ex is equal to NP and variance sigma square is equal to NP into bracket 1 minus p for 0 less than p less than 1. Then 1 becomes this equal to alpha probability of x minus np mod of this greater than equal to epsilon. Here epsilon is root n less than equal to sigma square, that is sigma square np bracket 1 minus p, and epsilon square, this epsilon square is root n whole square. We set epsilon here root n. So this is the probability. So obviously 0 less than equal to alpha. Any probability lies between 0 and 1 value. So this equal to this cancel, n and cancel. So p 1 minus p into 1 minus p. So 0 less than equal to alpha less than equal to p into 1 minus p. Now we let this ap equal to p into 1 minus p. So p minus p square and f dash p equal to 1 minus 2p. So for optimum value of f dash p equal to 0, so p equal to half. If we draw the graph, the p-axis and this along the y-axis is p, so then we get p equal to p into 1 minus p, and this is the graph, and this, so this is the origin, and this point is 1 0, and this point is 1 by 4 comma 0, and this point is half comma 0. So p equal to half, p equal to half. So for optimum this. Now if double dash p is negative, so if p has maximum at p equal to half, and this maximum value is f of half, that is equal to 1 by 4. So obviously alpha lies between 0 and 1 by 4. Hence the correct option is 1. Question 8. A coin is tossed 4 times and P is the probability of getting head in a single trial. Let S be the number of heads obtained. It is decided to test H0 such that P equal to half against H1 such that P equal not equal to half using the decision rule. Reject H0 if S is 0 or 4, then the type 1 error is what? Here, null hypothesis is not such that p equal to half, probability half, and alternative hypothesis H1 such that p not equal to half. Let capital X denote number of heads when a coin is tossed n times. Then capital X is a binomial NP-variate. That is, X is a binomial B n comma p where 0 less than p less than 1. P is the probability of getting head. Now here in this question, a coin is tossed 4 times, so here n equal to 4. So here capital X is a binomial 4 comma p variate. Now the probability of capital X equal to small x. So this equals to 4cx p to the small p to the power x bracket 1 minus p to the power 4 minus x, where small x equals to 0, 1, 2, 3, 4. Now probability of type 1 error, this equals to the probability of capital X belongs to the critical region W, and when H0 is true. So capital X belongs to W means that X belongs to critical region. X belongs to critical region, so this rejected. So type 1 error is the probability of rejecting H0 when H0 is true. When H0 is true, but we reject. So this is the probability of rejection of H0. Here critical region W is the set of x equal to 0 and 4 is this, because here reject H0 if s is 0 or 4. So this is the probability of x equal to 0, such that probability of half plus probability of x equal to 4 when probability half. So x equals to 0, that means 4 x equal to 0, 4c0 half to the power 0, and this half to the power 4 minus 0, 4c4 half to the power 4 half to the power 4 minus 4. After simplification we get 1 by 8. So correct option is 3. Correct option is 3. Question I. Two random variables capital X and capital Y have least square regression lines 3x plus 2y equal to 13 and 6x plus y equal to 1. The correlation coefficient Rxy has value. The regression lines are 3x plus 2y equal to 13, 6x plus y equal to 1. Solving 1 and 2, we get x equal to minus 11 by 9, y equal to 25 by 3. This is the solving with this. So mx, that is the mean of x, equal to minus 11 by 9, and my, that is the mean of y, is 25 by 3. Hence the lines 1 and 2 meets at the point minus 11 by 9, 25 by 3. Let equation 1 be the regression line of y on x. Then from 1 we can write y equal to 13 minus 3x by 2. Now this is the y minus my, so value of my is this, so y minus 25 by 3 is equal to 13 by 2 minus 3x by 2 minus 25 by 3. So after simplification we get y minus my equal to this byx bracket x minus mx. So byx, regression coefficients of y on x, equal to minus 3 by 2. Similarly, if the equation 2 is the regression line of capital X on capital Y, then we write small x equals to 1 minus small y by 6, and this x minus mx, here mx is minus 11 by 9, so write x plus 11 by 9, this is equal to 1 by 6 minus y by 6 plus 11 by 9. And after simplification we get x plus 11 by 9 equal to minus 1 by 6 bracket y minus 25 by 3. So comparing with this, x minus mx equals to bxy bracket y minus my. Bxy, that is the regression coefficient of x on y, equal to 1 minus 1 by 6. So correlation coefficient rho square equal to byx into bxy. So we get 1 by 4 this, so rho equal to plus minus 1 by 2. Since byx is negative, so obviously sign of rho is negative. A sign of rho is same as the either sign of byx or bxy. So the correlation coefficient Rxy in the given problem, this equals to minus half. Hence correct option is 2. Question J. In case of fitting a bivariate data exponentially to y equal to a b to the power x, we may fit a straight line if what? Here y equal to a b to the power x. Taking logarithm to the base e on both sides, we get log y equal to log a into b to the power x. So log a plus log b to the power x. So log a plus x log b. So log y equal to log b into x plus log a. Here log b equal to capital B, log a to the base e equal to capital A. A and b are two constants. So this represents a straight line. Log y is plotted against x for fitting the straight line. If we fit the bivariate data exponentially as uh, y equal to a into b to the power x. Hence correct option is 1, log y is plotted against x. Thank you for watching this video. This completes the MCQ 2022.